One last trig function to go, the cosecant. Let's take a look at its graph. Again, I'm going to think of it like I've been doing the other ones, because I know about sine x and I know about how rational functions work and how numerators and denominators tell me things. I'm going to look at this here. So I'm going to start with the graph of the sine x in blue. Here's my standard sine wave, one cycle in both directions there. So 2 pi is where that is. Pi is right there, minus pi, and minus 2 pi. Here we go. That's my sine curve. In red, I'm going to draw the cosecant. All right? The cosecant is the reciprocal of the sine. The cosecant will equal 0 whenever that numerator is equal to 0. But just like secant, that numerator is a 1. It is never equal to 0. On the other hand, the denominator is sometimes equal to 0, right? Sine is equal to 0 right here. That means the cosecant is going to have a vertical asymptote, because if you try to divide by 0, something's going to go wrong. We got vertical asymptotes at the pi's, because that's where sine has x-intercepts. When sine is equal to 1 here at pi over 2, at pi over 2, when sine is equal to 1, the reciprocal of 1 is also 1. So the cosecant and the sine match up right there. Likewise, at 3 pi over 2, the sine is equal to minus 1. And so the cosecant is the reciprocal of minus 1, which is also minus 1. It's right here. Right? Reciprocal of a positive number is negative. What? Reciprocal of a positive number is positive. Reciprocal of a little number is big. So anyway, these little positives are turning into big positives, and the closer you get to 1, the closer they are to the same thing. The reciprocal is equal to itself at 1, and then it gets big again. Once the sine is negative, the cosecant is also negative. Wow, that was ugly. It comes in here flat. Anyway, this looks a lot like the cosine. It looks like the secant curve, but it's shifted over. It matches up with the sine. Right? The sine I just draw in for a guide, and then to get me to draw the secant in. I can see where the asymptotes are, because right where the sine crosses the axis is where the secant is going to have its asymptotes. I can see how low the cosecant comes, because that's where the high as the sine goes. Cosecant has asymptotes at the pi's. It's got its low points and its high points at the pi over 2's. Okay. And of course, we'll do one more graph on the graphing calculator. Here's the one we had from last time with the secant. So let's change this now. Let's change this, clear that one out and put a sine in instead. Alright, and let's get rid of the secant and put a cosecant in its place. Cosecant, there we go. X, save it, draw the graph. I don't know if you saw that really fast, how it was the old graph and it moved over to this graph, because now I've got the sine in there in blue and the cosecant in there in red. Okay. The sine and the cosecant are reciprocals, and you can see that in the relationship of the graphs. Little becomes big. Reciprocal of 1 is 1. 0 becomes an asymptote when you take the reciprocal. There you go. There's the cosecant.